Okay, so some of you wanted to know why the energy stored in a capacitor is not equal to the charge on the capacitance times the potential difference between them. And I made another video, but it's really long, so here's a second version where I try to explain why. So if the potential difference were the same all the time, even as we added more and more charge to the capacitor, then the energy stored as we go from some zero amount of charge to some charge Q would indeed be a rectangle. This would be the energy stored in the arrangement, and that would be Q delta V. But, here's the big but. We know that the potential difference across a parallel plate capacitor, for instance, is ED, where E is 4 pi K eta. So this is charge per unit area times D, right? So this potential difference depends on charge. It's 4 pi K D over A times Q. So as you add Q, if you start with no charge, your potential difference is really, I'm going to put real, is really zero. And it's only by the time you get up to Q that your potential difference is that, right? So as you add charge to the capacitor, you're also increasing the voltage from 0 to nothing. So this is really a half. It's not the full rectangle. Kind of like the displacement for objects with constant acceleration is not equal to rate times time, because rate times time, it's not that rate the whole time. It's only the rate at the end anyway. So this is a half. So this isn't right. It should be really UC equals 1/2 Q delta V. And this agrees with what we derived from our integrals before.